Hi, welcome to es201 Computer Techniques. This is the first class of the first week, and the topics today, in addition to some basic introductory stuff, I will discuss C-in, C-out, which are both known as stream operators. First, just a little bit about myself that I'll be teaching the class. My name is Rourke Peterson. I'm an associate professor and I'm the department chair in mechanical engineering. In terms of my research areas, I work with cold climate heat and mass transfer. In Fairbanks, you're probably familiar with frost heaving of roads and buildings, and that's one example of the type of research that I'm interested in. I'm also interested in renewable energy integration, such as occurs in a lot of the rural parts of Alaska in terms of integrating wind turbines, solar, and wave and river energy into their energy mix. And then finally, I do some work with volcanic ash dispersion modeling. This is a numerical model, and this is where a lot of my programming experience comes from, primarily in the C++ language. This is about 40,000 lines of code in this model. It's called Puff UAF, and there's a link there that you go ahead and get more information if you're interested in it. But I do have a pretty extensive background in C++. So let me just mention the course goals. These are the overall course goals. There's three that are important. One is to gain a basic understanding of computer science. This is not a comprehensive computer science class. We just want a basic understanding of it. So some of you may actually already have basic computer science skills, and this actual goal is already met for you. But there's a couple other important components of this class. We'll be developing what I say is a working knowledge of C++ and MATLAB. So here we're specifically going to look at two languages, C++, which is what we'll cover in the first half of the class. This is known as a low-level language. This is a very powerful language, but it's a little bit more difficult to write programs in initially, particularly if you have no programming experience before. This is a language that needs to be compiled. We'll talk about the advantages and disadvantages of that. Then the second half of the class, we'll look at MATLAB. This is known as a high-level language or a scripting language. It's a little easier to work with. Many people find the second half of the class a little easier than the first half of the class. And we'll be looking at that as well. These are two languages that are used very commonly in engineering, and they both have their advantages and disadvantages, and we'll be talking about that through the semester. So these are kind of two ends of the spectrum in terms of programming languages. There are others out there, but these are the two that we use in this class. And the third thing that's an important course goal here, and this is what differentiates this class from just a straight-up computer science class, is we will spend a fair amount of time learning how to develop algorithmic approaches to solving problems. Each one of your homework problems and lab assignments, you'll have a problem that you want to do. There's a goal that you want to accomplish, and you need to come up with what's called an algorithm, an approach in order to accomplish that goal. A very simple example of an algorithm is the goal would be to sort numbers, and your algorithm may be to consistently look at pairs in a list and then just flip them if the one below it is greater than the one above it. For example, there would be a way to go ahead and swap them into ascending or descending order. So there's an example of an algorithm. There's other sorting algorithms, and it turns out that sorting algorithm, known as bubble sort, is actually not particularly efficient. But there's a lot of ways to accomplish it. In fact, you'll see me often talk about more than one way to skin a cat is my term. There's more than one way to solve computer science problems. So there's a link here to a video you might want to look at if you get a chance here. And this actually shows someone that develops an algorithm for solving the Rubik's Cube. And so what you get an idea is someone that, as they get better and better with practice, they're actually able to solve problems very quickly. You may find in this class it takes you a while to solve engineering problems using a computer, but hopefully by the end of the class you increased your skills with that. Let me just mention a little bit the way the course is going to go, and you've probably seen diagrams like this before in terms of learning process. If the class accelerates too quickly, that's like you see over here on the left, this really steep curve, it's pretty much impossible to keep up, and most people are not able to be successful in a class like that. So we won't do that. We'll go in the middle road here, where we'll try to take a gradual pace. So the first few weeks, for some of you, may be very easy, particularly if you have some background in computer science previously, so we'll go ahead and move up slowly. Now, you don't have to have any previous programming experience, and so you may find the first couple of weeks actually somewhat challenging as well, and that's going to be fine. But my goal is that it never becomes too challenging. It always goes at a consistent pace, and we keep adding at a constant rate. So what we won't do at the end is hopefully exhaust you by going up too steeply and going up too long. We'll be taking breaks as we move through. Okay, let me just talk a little bit about the C++ language. This is the one we're going to use in the first half of the class, and I'll talk about how that's relative to what's called the C language. We will be focusing on C++, and the analogy I like to use for C++, and this pertains to C as well, is it's kind of like a race car. Think about if you were to go ahead and build a race car, you're not going to put anything on that race car that you don't need. You're going to put some wheels on there, a way to go ahead and steer it, a seatbelt if that's required by the rules, and an engine. And you're not really going to put anything else on there. You're not going to have power windows, and you're not going to have a radio, and you're not going to have a sunroof on there. In fact, you may not even have doors on there. You put on just what you need. When you write C++ programs, you're going to be doing the same thing. You're going to put in just what you need, and it's going to make it very fast and very efficient, but it's only going to accomplish that one goal. And if you want to do something else, you're going to have to add that component to your program. So that's going to be in contrast. We'll see MATLAB. MATLAB is a very different one. It comes with all the bells and whistles. In terms of C and C++, C is a language, and then C++ is a superset of that. It encompasses everything that's in the C language plus a couple other things with it. And so some of those things that it has a couple of extra what are known as keywords, and we'll talk about what keywords are next week. And also the way that you use what are called include statements are written just slightly different, and we'll talk about what that is. And then primarily the biggest difference is that C++ has classes, which means that it is object-oriented, so you have objects. So an instance of a class is known as an object. And we'll talk about that the last few weeks that we work with the C++. We'll go ahead and look at some classes in there, and that's the important thing that C++ has. Everything that is in C is in C++. So you're going to be going and getting the more comprehensive language in C++. But since we'll be looking at classes and using some of the objects that are not in C, this is a C++ class. Let me just talk where C++ is relative to other languages. C++ is known as a structured language. We'll see that you kind of have to include a template every time with it. It's got the same basic structure with it. So that's what's shown over on the left-hand side. And this is in contrast to MATLAB. We'll look in the second half of the class, which is known as a scripted or interpreted language. It's a little quicker to go ahead and get some information from. In fact, you can write just one command, and you can get something back from MATLAB. C++ requires about 10 lines of code before you can actually get it to do anything. So there's kind of the difference between a structured and what's known as a scripted or interpreted language. And we'll be looking at those two, and they have various, as I say, different pluses and minuses. If you've heard of Java, Java is very similar to C++. It's completely object-oriented. If you know C++, you'll be able to learn Java very quickly. Analogy would be like Italian and Portuguese. They're Spanish and Portuguese. They're very, very similar languages. And you'll find that there's a lot of crossover between them. But Java is completely object-oriented. C++ can be object-oriented. But they're more or less the same, and they're both structured languages. We just happen to use C++. Java is very similar. Another language you've probably maybe heard of recently, it's fairly popular, is Python. And what Python is particularly interesting because it is actually both a structured language, but you can use it as a scripted or interpreted language as well. It's very powerful. It's actually very fast. The structured languages tend to be faster. They're more like the race cars. And actually you can make very fast, efficient Python code, but you can also operate it in a scripted language. And so it's actually another very popular programming language in the last few years. We just don't happen to use it in this class. All right, so let me just talk a little about structured languages. Structured languages require a template. And the analogy I use is, for example, if you were to be writing essays, every essay you write would be different. But if you're in an English class, every time it says you're going to write an essay, you'd probably pull out a piece of paper, maybe put your name and the date up in the corner of it, and maybe what class it is due for. And that's kind of like the template. And then you go ahead and write the essay, which would be different each time. Same things when we write a C++ item. You're going to go ahead and start with a template. And it'll look something like this. Those things shown in green are known as comments. You might put some comments at the top. It's like writing your name on it, what the assignment is and your date. And then you'll have some things like I talked about these include statements. This thing says using namespace standard. We'll talk about that. You kind of just write that verbatim every time. And then this thing there says int main, and then these curly brackets. This thing returns 0, and that's just every time. It'll be in there. So just write that every time. And then what's different is there where your code here, you're going to go ahead and be writing your program in there, and that's what varies each time. And so every program is going to have kind of the same little header and footer as one way to look at it. And that's the template or the structure that you need to have in C++. And it's just the way that these structured languages go because they're very pedantic. They require this particularly structure to it. So let me just mention a little bit about Mr. Pedantic. Computers are very, very pedantic. You have to have be very, very precise at what you have. If you're putting a comma in the wrong place or a semicolon in the wrong place or a space where there shouldn't be a space, it will often fail. In fact, the video I linked to here is an example of an Alexa device terribly failing because it is actually not, it is very pedantic and it is not getting exactly what it wants as input. Sometimes you'll find that very frustrating. But there's a reason we want computers to be very pedantic. And if you think about it, computers, and a good example of a embedded computer controller would be these self-driving cars. You don't want those to ever misinterpret. You want them to be very predictable in the way that they respond. And so there's a lot of instances where we want to make sure things are predictable. And then that the consequence of that is that they're going to be very pedantic. So there'll be oftentimes in lab, and you might be a little frustrated because you're just simply missing a semicolon or something like that. But the TAs will be there to go ahead and help you move through that. And with practice, you'll get a little bit better with being able to pick that up. And that's just a consequence of writing computer code. All right, let me just talk about a couple concepts here, which is writing to and from the screen. It's the most basic thing we want to do in computer programming, and they're done with two tools. Those tools is called cout and cin, and I can think of it as we're writing in the C language, and we want to either output to the screen, or we are writing in the C language, we want to do input to the screen. So just in terms of completeness, I talked about this being an object-oriented class. It turns out that cout is an object. It's an object of the class called ostream. So nothing you need to worry too much about, but just recognize that this is already kind of talking about the C++ aspect because we're using cout. There's two operators, so each class has a set of operators. This one has these two operators. One for cout, which is that first set of angle brackets that point to the right, and then cin has the second operator, which is the ones that point to the left. And I'll show you some examples of how those work here in just a moment. So for doing output, we want to write to the screen. Right? So we're going to use cout. There's our tool. And one way to think of it is whatever we want to write to the screen, we're going to go ahead and put those angle brackets and shove it over into our object on the left. So that's going to go ahead and write hello there to the screen. So if I wrote this, cout, two angle brackets, in double quotes the words hello there, and then a semicolon, which is the way we end our sentences in C++, it would go ahead and write the words hello there. So this is if you stuck this into the template, right where it said your code here, and compiled that program, it would write to the screen hello there. We'll look at variables next week, and if you'd stored something in the variable, you would go ahead and just give it the name without double quotes, and that could go ahead and as variable, the name of that implies, is you can put various things in there, and we'll see how to do that, and then it's going to write whatever is stored in there. So maybe the name is varying with time. You can combine these together. So if I wanted to write hello there, and maybe stored in the variable name is my name, Rorik, then this would write hello there and then Rorik. But since hello there is what's called a stream literal, it's in double quotes, I want to literally write that, and name is a variable, I have to separate that. So each object that you want to go ahead and send to the output, you go ahead and separate with a set of angle brackets. There's a special kind of part of the cout object is endl, which is an end line. This is just like the carriage return or the enter on the keyboard. So this would write hello there, and then Rorik, for example, and then it would actually go to the next line. So it's like hitting return or enter on a keyboard or typewriter. If I want to do input, this is the opposite. I'm going to use the input cin operator. And what's different here is it reads what the user types on the screen. And so this is why the angle brackets go to the right. That object cin is going to take whatever you type on the screen and put it into what's on the right. So for example, here it's going to put it into that variable. So if I wanted to actually be able to put in to name my name Rorik, I would go ahead and after that line of code, the computer would sit and wait for me to type something. I would type R-O-R-I-K, hit enter, and it would put those 5 letters into that variable called name. You can't obviously just put things into what's a stream literal because it's literally Rorik, and so if I typed E-R-I-C, Eric, at the screen, it couldn't then stick it into something that said Rorik, and so that's actually an error. So it's going to be a compiler time error. So that would not work, and it actually wouldn't compile. If you want to go ahead and put in multiple things on one line of code, so if I want to put Rorik space Peterson, and I want to put those into 2 different variables, I'd separate them with these 2 sets of angle brackets. And then the computer, I would write Rorik, and then hit either a space or an enter key to go ahead and separate that from the next thing. Maybe I'd write Peterson, and then hit a space or an enter, and it would put that into that second variable name. So there's kind of the ways to use some examples of cin and cout. And the Xi book you'll see has many, many examples of using cin and cout and gives you some practice with it. All right, so that's it for this first class. I say next week, it's actually next class. And what we'll be talking is a little bit more about syntax and errors as we move into this first couple chapters of this class. All right, I will see you then.